All right, so the end of today, so today is September 9th, and I sent you home with a nomenclature handout. And if you're a little bit stuck with how to get started with doing this, I'm gonna actually go over the example that's on here. I'm also going to talk about HDI, but not the calculation, we'll do one in class, but how this relates to HDI and that formula that's on the sheet for you. And then what I also am going to do is I'm going to pick one of these problems randomly, and I'm going to actually answer it as well. And so you can check some of your answers, but make sure you bring this back to class. So if you're watching this before our next class, hopefully this will help you get started for nomenclature. So on the sheet is the structure. So here is the structure that I have on the sheet. I didn't put the numbers on there because I want to go over something. I drew it twice for a reason. And as you practice and feel comfortable, I want to emphasize that it takes some practice. But once you got it, it's actually fairly easy. I would say nomenclature eventually is the easiest thing that we'll do. But let's get kind of started. So the first thing that we want to do is find the longest chain. And so if I were to count 1, 2, 3, that's clearly not the longest chain. And we can kind of tell it's not, right? And then, so if I keep going, 3, 4, 5, 6, 7, that's probably the longest chain, because if I went any other way, I'd get different numbers. Now, notice that even if I went this way, it's still 7, so it really wouldn't matter. Now, I've identified my longest chain, so the first thing that I'm going to want to do is I'm going to then say 7 carbons, and there's no double bonds here, so this is just heptane as the ending name. So I'm just going to write that down. So I'm really just going to write down some notes for now, and then eventually we're going to solve this. Okay, so the answer is actually on your sheet, but to kind of run through this. Now, the next thing that I want to do is find my substituent. So anything that's not numbered is a substituent. So I have a substituent here, which is 1 carbon, so that's a methyl. I have a substituent coming off of here, or another name is branch, and it's 2 carbons, so this is called ethyl. And then another substituent, which is called, again, methyl. So I have 2 methyls, and I have 1 ethyl. So our next thing that I'm going to do is I'm going to see where it's branching off. But what I'm going to do on the one below it is I'm going to number it in a different direction, and we're going to compare. So if I go 1, 2, 3, 4, 5, 6, 7, and if I numbered it, again, I still have a methyl, and you should still have a methyl, and you should have an ethyl. But what I'm going to do is I'm going to use the numbers from the top and the numbers from the bottom one to determine our locants. So what we need to do now is, now that we know heptane is the end, I need to find my locants. On the top one, I have a methyl on position 2 and an ethyl on position 3, and my second methyl is coming off of 6. On the bottom one, I have a methyl on 2 right here, another methyl on 6, but my ethyl is on 5. So overall, all the numbers are the same, except for on the bottom, my ethyl ends up being a higher number. And because it ends up being a higher number, we ignore that pathway. So I'm going to skip this pathway, the bottom one, and I'm going to focus on this. So here's what we have so far. We have heptane, that's the end part. And now at the beginning, I have 2 methyls, and they're in position 2 and position 6. I have my ethyl in position 3. And so now let's try to put it together. Because I have 2 methyls, regardless of the number, I have to tell it what number it is. So even if they were both on the same position, I would have to say that what number. So if they were both on 2, for example, then I would say 2, 2. But I also have to say how many there are. I know it sounds kind of redundant that you have to say both, but then you put die to represent the number being 2, 2 of them. If it were 3, it would be tri. If it's 4, it's tetra, and then we kind of stop after that. There's pentyl after that, hexyl after that, etc. There's a bunch of other stuff, but we kind of stop at tetra. So the second thing that we do is we name them alphabetically based on the substituents. I don't care about the di and the tri, those don't matter. They don't count. And so I'm going to name them alphabetically. So ethyl comes first. And then we always separate our numbers, which are our locants, from our substituents. So it's 1 ethyl. Now we're going to put the methyls. So 2, 6, dimethyl, ethyl before methyl, heptane. Okay. Now, if you put the methyl first, according to the rules, that's wrong because we alphabetize them. Now, there are some other rules, although it doesn't apply to this thing. So if for example, you have 2 substituents and they're equally distanced, so let's pretend that you have substituent A and substituent B, and substituent A in one direction could be 2 and then 5 for B, or it could be 5 and then 2. If they're equally distant, then the tiebreaker is alphabetical. Another rule is, what if you have a whole bunch of substituents and you want to decide, let's say, the number doesn't really make much of a difference. Let's say you had, again, let's pretend you have A and B at position 2, and then you have C at position 5. So this would be like 2 and 2, right? So this could be 5 and 5 or 2. Let's say if you swap them, then you would go by the one that has more of the higher substituents. So that would be kind of your tiebreaker. So those are some additional things. Now, let me just randomly, I'm going to randomly pick a question, but I'm going to do this from the alkene side and the alkyne side. So there are 2 little asterisks on the under the alkene and alkyne side, and I'm going to do both. So this is 2, 3 di, and so we're going to actually figure out the structure based on the nomenclature that's written for the first one, and then the second one I'm going to name it based on the structure. So this is the first one. So if you skip, it's almost towards the back. It's not little back page, but almost the end. So this is one of the questions. So it says 2,3-dimethyl 2-butene. Now I'm going to tell you there is another way of naming this that is acceptable. This is what we call the older nomenclature, but it's still acceptable. There's a newer one, and I'm going to tell you what that is after. So my first step, my first thing is to do the very last part of the molecule. So, but I'm going to focus on the number of carbons. So I have 1, 2, 3, 4 carbons. Then it says, this number says that the start of my alkene part is going to start on my second. So I'm just going to randomly say this is 1, 2, 3, 4. So if I'm saying this is 2, my alkene starts here. So the alkene starts on 2, right? Now it says on position 2, I'm going to put a methyl. So I just go ahead and put a methyl. On position 3, I put a methyl. So that's the answer to that question. I'm going to do one more, which is an alkyne. So another question on your sheet gives you this molecule, and we're going to name it. So if I find the longest chain, I can either go 1, 2, 3, 4, but I could also go 1, 2, 3, 4. But if I notice, it kind of doesn't make a difference because the alkyne still starts no matter which direction on position number 2. So I have 4, so it's bute, but since it's a triple bond, it's -ine at the end. And since it's starting at position 2, it's 2-butyne. Now, remember I said I'm going to come back. This is kind of considered a slightly older way of naming these, and it's 100% okay. There's another way, and the newer way is because as we start naming these molecules, we can run into some nomenclature problems next semester. Not as much this semester, maybe a little bit this semester, but one of the things that we run into is what if the ending part of the name has more than one functional group? So here I have an alkene, and the bottom one I have an alkyne, but what if I had some other stuff? So the other way of naming this is to put the 2 in between the number of carbons and the alkene. So I can name this 2,3-dimethyl bute-2-ene. The other way to name this one is similar, bute-2-ine. You just put the 2 in between. So here's an example, and you don't need to know this one quite yet. Here's an example of where this becomes a problem. So in a molecule like this, although you don't need to know how to name this like today, but you will eventually. Just so you know, the alcohols get preference in naming, and on your sheet, the very back page on preference is not on the printed sheet that I gave you, but it is on the online. I have another page on the online one. So this alcohol could get priority 1 or the double bond, but it turns out based on priority this is 1, so we actually have to start here 2, 3, 4. And so this is butene, and the alcohol gets all at the end. And so how do you know where do you place the 1 and the 4? So this is where the confusion comes, and so we put the 1 and the 3. You put the 3 for the alkene in front of the ene part, and you put the 1 for the alcohol in front of the alcohol part. That's why that came up, is because then it's like if you put all the numbers in the front, you're like, well, which one does it belong to? And that's the confusion. This is just a side note. Don't worry about this one quite yet, okay?